of reactions, like this one, occur in aqueous solutions, meaning they occur in water. In this case, two aqueous solutions created a solid, or a precipitate, that's settling at the bottom of this beaker. You can symbolize a precipitate with a downward arrow. If we were able to zoom in and look at the two starting solutions at the atomic level, you would see a bunch of ions. In aqueous solution, ionic compounds break up into their representative ions. And when they react, the precipitate is an ionic compound which does not dissolve in water, so it stays solid. But some of the ions are not changed at all. They started as free-floating ions and they stay free-floating ions after the reaction has occurred. These are called spectator ions because they watch the reaction happen just like spectators watch a sports game happen. Now we can write the equation a little bit differently. If we write out the equation with each ion written out instead of the ionic compounds, we can get a more truthful version of the story. 4 different ions were mixed together. 2 of them combined to make the precipitate, copper and sulfur, and the other 2 ions were spectators. You can easily spot the spectator ions in a complete ionic equation because they will be written on both sides of the equation. The 2 chlorine ions and the 2 hydrogen ions are the spectator ions in this case. If we cross them out, we can clean up the equation, and we get a net ionic equation. The net ionic equation shows only the particles that are involved in the reaction, and it's balanced with respect to both mass and charge. So here we have 1 copper atom and 1 sulfur atom on both sides of the equation, and the 2 plus and 2 minus charges add up to 0. And there's 0 on the other side of the equation. So this is a balanced net ionic equation. But let's look at another one. Lead reacts with silver nitrate in a single replacement reaction. First, we have to write out the skeleton equation. We start with solid lead, and we'll end with solid silver because the metals switch positions in a single replacement reaction. Next, we just have to balance it by adding a coefficient, a 2 in front of silver nitrate and a 2 in front of silver. Now it's balanced. Now we can write out the complete ionic equation. Write every ion for any aqueous chemical, but don't break up any solids. Identify the spectator ions by seeing them on both sides of the equation, and cross them out. Then you can write the net ionic equation. The number of atoms and the charge is the same on both sides. There are 2 positively charged silver atoms and a lead atom with a 2 plus charge, so those are equal. You can predict the formulation of a precipitate by using the general rules for solubility of ionic compounds. Now, how do you know what the rules are? You can look them up in a chart. Most compounds are soluble, with a few exceptions, and the carbonates, phosphates, chromates, sulfides, and hydroxides are mostly insoluble, meaning they will most likely form the precipitates. Using these rules, you can figure out which product will form the precipitate. So, lead 2 sulfate, as an example, is insoluble, a precipitate, because the lead 2 ion is one of the exceptions to the general sulfate rule, making it insoluble. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe, and follow me on Twitter @SciencePet.